The rain hammered against the windows of the Pentagon conference room as General Thomas Harrison stared at the maps covering the entire wall. Red pins marked American military bases scattered across the Pacific Ocean, North Africa, and Europe. Each pin represented thousands of soldiers who needed shelter, and Harrison knew they had almost nothing to give them. It was March 1941, and everyone in that room understood war was coming. Hitler's forces had conquered most of Europe. Japan was expanding across Asia. America was preparing to send millions of men to fight in places they had never heard of, from frozen islands in Alaska to burning deserts in Africa to steaming jungles in the Pacific. But there was a problem nobody wanted to talk about. Where would these soldiers live? Commander Robert Sullivan stood up and pointed at photographs scattered across the conference table. The pictures showed destroyed military bases in the Philippines and Hawaii. Wooden barracks lay in splinters after tropical storms. Traditional buildings took months to construct and required skilled carpenters who were desperately needed elsewhere. Worse, these structures burned easily when hit by bombs or caught fire from cooking accidents. Sullivan picked up one photograph showing a base in Panama. A hurricane had swept through just 2 weeks earlier. Every wooden building had collapsed. Soldiers had survived by huddling in concrete bunkers, but all their supplies, medical equipment, and communications gear were destroyed. 3 men had died not from enemy action, but from a simple storm that an engineer named George Fuller spoke next. He had spent the last 6 months visiting military bases across America and overseas territories. What he reported made everyone in the room go silent. Traditional construction methods were failing everywhere. In Alaska, buildings froze and cracked. In the Pacific Islands, humidity rotted wood in weeks. In North Africa, sandstorms buried everything. And everywhere, bombs destroyed conventional structures with terrifying ease. Fuller explained that building a standard wooden barracks took a construction crew of 12 skilled carpenters about 6 weeks to complete. They needed trucks full of lumber, thousands of nails, and perfect weather. If it rained, work stopped. If materials arrived late, work stopped. And when the building was finally finished, one well-placed bomb could destroy it in seconds. The numbers were staggering. Military planners estimated they would need shelter for at least 5 million American servicemen within 2 years. At the current construction rate, they would need 50,000 skilled carpenters working nonstop for 5 years. America did not have 50,000 carpenters to spare. Those men were needed to build ships, aircraft factories, and weapons plants. General Harrison asked the question everyone was thinking. What if they used tents? An Army quartermaster shook his head. Tents worked for short deployments, but fell apart in harsh weather. They offered no protection from bombs or artillery. Mosquitoes carrying malaria flew right through the fabric. And tents could not be used for hospitals, command centers, or supply warehouses. Someone suggested concrete bunkers, but Fuller quickly dismissed that idea. Concrete required massive amounts of steel reinforcement, skilled workers, and heavy equipment. Building a single concrete structure took months and cost a fortune. America needed thousands of shelters built quickly and cheaply. The meeting was going nowhere when a young naval architect named Otto Brandenburger raised his hand. He had just returned from England, where he had seen something interesting. The British were using curved metal shelters called Nissen huts, invented during World War I. These semicircular buildings were made from corrugated steel and could be assembled relatively quickly. Brandenburger spread out his sketches on the table. The British design had potential, but serious flaws. Nissen huts were dark, poorly ventilated, and still required skilled workers to assemble. They leaked in heavy rain and were difficult to insulate. But the basic concept was sound. A curved steel structure was stronger than a flat one and used less material. General Harrison looked at the calendar on the wall. It was March 20th. Japan had already occupied French Indochina. German U-boats were sinking ships in the Atlantic. Everyone knew America would be at war within months, maybe weeks. They did not have time for lengthy research and development. Harrison made a decision that would change military history. He turned to Brandenburger and gave him an assignment. Take a team to Quonset Point Naval Air Station in Rhode Island. Study the British design. Improve it. Make it faster to build, easier to ship, and strong enough to survive bombs, storms, and extreme weather. And do it all in 60 days. Brandenburger felt his stomach drop. 60 days to design a completely new type of building? It seemed impossible. But he looked at those photographs of destroyed bases and dying soldiers, and he knew they had no choice. The meeting ended, and officers hurried out to their next crisis. Brandenburger gathered his sketches and headed for the door. As he left, he heard General Harrison speaking quietly to Commander Sullivan. "If this does not work," Harrison said, "we will lose thousands of men before the enemy ever fires a shot." Brandenburger caught the next train to Rhode Island. He had 60 days to invent a miracle, and the clock was already ticking. Otto Brandenburger arrived at Quonset Point Naval Air Station on March 23, 1941, with a team of 12 engineers and designers. They had 57 days left. The base commander gave them an empty warehouse, a budget barely enough to buy coffee, and a warning. The Navy brass thought this whole project was a waste of time. Brandenburger did not care what anyone thought. He pinned the photographs of destroyed barracks on the warehouse wall, where his team could see them every morning. Below the photos, he wrote in large letters, "Soldiers are counting on us." The team started by studying everything they could find about the British Nissan Hut. They built a full-size mock-up using the original British plans. Then they tore it apart piece by piece, analyzing every weakness. The list of problems was long. The British design required special tools, complicated assembly instructions, and skilled metalworkers. The ventilation was terrible. The door design was poor. And worst of all, it took a crew of 8 men 3 days to build one hut. 3 days was 3 days too long. A structural engineer named Peter Chen suggested they focus on the curve itself. He spent 2 days calculating angles and stress points. On the third day, he rushed into the warehouse with equations scrawled across a dozen sheets of paper. The semicircular curve was not just strong, it was nearly perfect. Bombs hitting a curved surface would deflect rather than penetrate. Wind would flow over the shape instead of pushing against flat walls. Snow and rain would slide off naturally. But Chen had found something even better. If they made the curve from lightweight corrugated steel, the structure would be incredibly strong while weighing almost nothing. The corrugations acted like built-in reinforcements, giving the thin metal tremendous rigidity. Another engineer, Margaret Collins, solved the size problem. She studied shipping containers, truck beds, and cargo holds. After testing dozens of configurations, she found the magic numbers, 16 feet wide and 36 feet long. This size fit perfectly on standard military trucks and cargo ships. It was large enough to house 20 soldiers comfortably, but small enough to ship anywhere in the world. The team worked 18-hour days. They tested different thicknesses of steel, various door designs, and dozens of ventilation systems. Every night, they gathered around tables covered with blueprints and argued about details that seemed tiny but mattered enormously. Should the door be at the end or the side? How many bolts were really necessary? Could they reduce the number of different parts? By April 15th, they had their first major breakthrough. Designer James Murphy invented an interlocking system where each steel panel connected to the next using simple tabs and slots. No welding required. No special tools needed. Just ordinary bolts that any soldier could tighten with a standard wrench. Murphy demonstrated his system to the skeptical team. He grabbed a panel, lined it up with the base, and pushed. The tab slid into the slot with a satisfying click. He added the next panel. Click. Then another. Click. Within minutes, he had assembled an entire section using only his hands and a single wrench. Brandenburger watched with growing excitement. This was not just an improvement. This was revolutionary. If Murphy's system worked for the entire structure, they could reduce construction time from days to hours. But time was running out. It was now early May, and they had less than 30 days left. The team decided to build a complete prototype and test it to destruction. If it failed, they would have to start over with no time left. They worked around the clock. Welders fabricated the curved panels. Carpenters built the wooden floor and end walls. Murphy supervised the assembly, making small adjustments to his interlocking system. After 4 days of frantic work, the first complete Quonset hut stood in the middle of the warehouse. It looked strange. The semicircular shape seemed almost alien compared to traditional rectangular buildings. Some of the team members worried that soldiers would hate it. But Brandenburger did not care about appearance. He cared about performance. The testing began. They blasted the hut with fire hoses to simulate tropical storms. Water ran off the curved roof without leaking inside. They used industrial fans to create hurricane-force winds. The structure barely moved. They heated one end with blowtorches while cooling the other with ice to test thermal expansion. The metal flexed slightly but did not crack. Then came the real test. The Navy provided several surplus bombs from World War I. They were small, only 50 pounds each, but still deadly. The team placed the bombs 30 feet from the hut and detonated them one by one. The first explosion shook the ground. Shrapnel tore through the air. When the smoke cleared, the hut had several dents, but no holes. The curved surface had deflected the blast just as Chun predicted. The second bomb was placed closer, just 20 feet away. This explosion was much worse. The noise was deafening. Metal fragments peppered the hut's surface. But again, no penetration. The structure held. For the third test, they placed a bomb only 10 feet from the hut. This was closer than any realistic combat scenario, but Brandenburger wanted to know the absolute limits. The explosion was massive. The concussion wave knocked several observers off their feet. Smoke and dust filled the air. When visibility returned, everyone held their breath. The hut stood intact. One panel was badly dented, but even that had not torn or failed. The door still opened and closed normally. The structure was still habitable. Commander Sullivan arrived the next day with 3 skeptical admirals. They walked slowly around the battered but standing hut. One admiral kicked the wall. Another examined the blast damage closely. The third admiral climbed inside and looked around. Finally, Sullivan turned to Brandenburger and asked the crucial question, "How fast can you build one of these?" Brandenburger smiled. They had timed their last assembly. 6 men with basic tools can build this in one day. Sullivan did not smile back. He looked deadly serious. "How many can you deliver by December?" "As many as you need." Brandenburger replied that it was May 28, 1941, 2 days before the deadline, and they had just invented the building that would help win the war. On December 7, 1941, Japanese aircraft attacked Pearl Harbor. America was suddenly at war, and the military needed those Quonset huts immediately. Within 48 hours of the attack, the Navy placed emergency orders for 15,000 units. By the end of December, that number had jumped to 70,000. Factories across America switched to wartime production overnight. The Great Lakes Steel Corporation in Michigan converted 3 assembly lines from automobile parts to Quonset hut panels. In Pennsylvania, a company that normally made water tanks began stamping out curved steel sections. Dozens of other factories joined the effort. The production process was surprisingly simple, which was exactly why it worked. Large sheets of steel went into rolling machines that created the corrugated pattern. Then hydraulic presses bent the sheets into the precise semicircular curve. Workers added the interlocking tabs and drilled holes for bolts. Each panel took less than 15 minutes to manufacture. Martha Henderson was one of thousands of women who joined the workforce to support the war effort. She worked at a factory in Ohio, operating a press that shaped door frames. Her shift started at 6 in the morning and ended at 6 in the evening, 6 days a week. The work was hard and repetitive, but Martha knew her panels would shelter soldiers fighting overseas. Her brother was a Marine somewhere in the Pacific. Every door frame she made might save someone like him. The factories produced components at an incredible rate. By early 1942, American industry was manufacturing enough parts to build 500 complete Quonset huts every single day. But building them was only half the challenge. The military needed to ship these structures to war zones scattered across the globe. The huts were designed to pack flat, which was their genius. Each complete hut broke down into a stack of curved panels, a bundle of straight supports, and crates of hardware. Everything fit into a space barely larger than a large automobile. A standard cargo ship could carry components for 200 huts in a single voyage. Loading docks in New York, San Francisco, and New Orleans operated 24 hours a day. Cranes lifted crate after crate onto transport ships bound for England, North Africa, and the Pacific Islands. The ships traveled in convoys for protection against German U-boats that hunted Allied vessels in the Atlantic. Cargo ship Captain William Morrison made 11 voyages across the Atlantic in 1942. His vessel carried Quonset hut components along with ammunition, food, and medical supplies. German submarines attacked his convoy 3 times. 2 ships were sunk, but Morrison's vessel made it through each time. He knew that losing his cargo meant soldiers would go without shelter in one of the world's most dangerous war zones. The Pacific Theater presented different challenges. Distances were enormous, and many island bases had no proper harbors. The Navy developed a solution: airdrops. Transport aircraft like the C-47 could carry disassembled hut sections and drop them by parachute to remote jungle bases. It was risky, and some shipments were damaged in the drop, but it worked. In February 1942, the first Quonset huts arrived at Guadalcanal in the Solomon Islands. A marine construction battalion called the Seabees received crates containing enough components to build 50 huts. Most of these men were not trained carpenters or engineers. They were welders, plumbers, and mechanics who had volunteered for military service. Seabee foreman Jack Riley opened the first crate with skepticism. Inside, he found curved metal panels, wooden frames, and a single-page instruction sheet. The instructions were so simple they seemed like a joke. Lay the foundation. Bolt the panels together. Add the end walls. Install the door. Riley decided to test the design. He selected 6 men with basic construction experience and told them to build one hut while he timed them. They started at 8 in the morning. By noon, they were attaching the door. By 2 in the afternoon, the complete structure stood ready for use. Riley could not believe it. 6 partially trained men had built a complete building in 6 hours. He immediately organized his entire battalion into assembly teams. Within a week, all 50 huts were standing. The Marines had housing, a field hospital, supply warehouses, and a command center, but the real test came 3 weeks later when Japanese bombers attacked the base. The raid lasted 30 minutes. Bombs and strafing runs destroyed tents, damaged equipment, and killed 3 Marines. When the attack ended, Riley inspected the Quonset huts. Several had shrapnel holes and dents, but not one had collapsed. More importantly, the Marines who had taken shelter inside survived without injury. In North Africa, the situation was different but equally challenging. British and American forces were fighting German and Italian troops across vast desert landscapes. Army engineer Thomas Webb arrived at a base near El Alamein in Egypt with components for 30 huts. The temperature was 115 degrees. Sand covered everything. Webb's team assembled the first hut in scorching heat. The metal was so hot they had to wear gloves to touch it. But once the structure was complete, something remarkable happened. The curved shape created natural air circulation. Hot air rose to the top of the curve and escaped through ventilation panels, while cooler air entered through the bottom. Inside the hut, the temperature was 15 degrees cooler than outside. Webb also discovered that sand simply blew over the curved surface instead of piling up against it. Traditional rectangular buildings in the desert required constant shoveling to prevent sand from blocking doors and windows. The Quonset huts shed sand naturally. By the end of 1942, Quonset huts were everywhere. In Alaska, they housed troops guarding against potential Japanese invasion. In England, they served as barracks for bomber crews preparing raids on Germany. In Australia, they became hospitals treating wounded soldiers from Pacific battles. In India, they stored supplies for operations in Burma. Soldiers began personalizing their huts, painting unit insignia on the curved walls, building wooden porches, and adding whatever comforts they could scrounge. Some huts became legendary. There was a hut on Guadalcanal that served as a church on Sundays, a movie theater on Wednesdays, and a boxing venue on Fridays. Another hut in England housed a secret planning room where officers prepared the D-Day invasion. The simple curved building had become an essential part of the American war effort, and the hardest tests were still to come. The typhoon hit the Philippines base at 3 in the morning on October 15, 1944. Wind speeds exceeded 150 miles per hour. Rain fell so hard that visibility dropped to 0. Navy meteorologist David Chun had tracked the storm for 3 days, watching it grow into a monster. Now it was here. The base housed 5,000 sailors and Marines supporting operations in the Pacific. Most lived in 200 Quonset huts scattered across the compound. Traditional wooden buildings held the officers' quarters and administrative offices. Everyone had been ordered to take shelter hours before the storm arrived, but Chun wondered if shelter would be enough. The typhoon's fury was beyond anything Chun had experienced. The wooden administration building where he had set up his weather station began to shake violently. Timbers creaked and groaned. Through the windows, Chun saw sheets of metal roofing tear away from a nearby barracks. The wooden structure collapsed within minutes, walls folding inward like cardboard. Chun and 3 other men abandoned the dying building and ran through the storm toward the nearest Quonset hut. The wind was so strong they had to crawl on hands and knees. Rain pelted them like bullets. When they finally reached the hut's entrance, a sailor yanked the door open and pulled them inside. 40 men were crammed into a space designed for 20. They sat in darkness listening to the storm rage outside. The metal structure groaned and flexed, but it held. Chun felt the building move slightly beneath him as wind gusts pushed against the curved surface. It was terrifying, yet the hut remained intact. At dawn, the typhoon passed. Chun stepped outside into devastation. Every wooden building on the base was destroyed or severely damaged. The officers' quarters had vanished completely, reduced to scattered planks and debris. Storage sheds were gone. The mess hall was a pile of wreckage, but every single Quonset hut stood upright. Some had dents. A few had damaged doors. One had lost ventilation panels, but not one had collapsed. Most remarkable of all, not a single person sheltering in the huts had been injured. Chun walked among the huts in amazement. He touched the dented metal walls, trying to understand how these simple structures had survived when solid wooden buildings had failed. The answer lay in the design itself. The curved shape allowed wind to flow over and around the building rather than pushing directly against flat surfaces. The corrugated steel flexed under extreme pressure but did not break. And the low profile meant the typhoon had less surface area to attack. Thousands of miles away in Europe, different challenges tested the huts in different ways. On June 6, 1944, Allied forces invaded Normandy. Within weeks, thousands of Quonset huts were being assembled on French soil to support the massive invasion force. Army medic Sarah Thompson worked in a field hospital housed in 4 connected Quonset huts near the town of Corinton. The curved buildings had been converted into surgical wards, recovery rooms, and supply storage. German artillery regularly shelled the area, and Thompson had seen shells land within 100 feet of the hospital. One morning, a German artillery barrage targeted the nearby fuel depot. One shell fell short and exploded just 30 feet from Thompson's surgical ward. The blast was enormous. Windows shattered in buildings across the compound. Thompson and 2 doctors hit the floor, covering patients with their own bodies. When the explosion's echo faded, Thompson cautiously stood up. The hut's metal walls were peppered with shrapnel holes, but the structure had not collapsed. More incredibly, the shrapnel that penetrated the walls had lost most of its energy. None of the metal fragments had traveled completely through the curved shell. The patients on operating tables were alive and safe. The hut's curved surface had deflected the blast wave and absorbed shrapnel that would have torn through wooden walls. Thompson realized she was standing in the safest building in the entire compound. From that moment, whenever artillery fire began, everyone ran for the Quonset huts. In the Burmese jungle, British and American forces fighting the Japanese faced a different enemy: climate. The humidity was crushing. Temperatures exceeded 100 degrees daily. Rain fell in torrents during monsoon season. Everything rotted, rusted, or grew mold. British officer James Patterson commanded a supply depot deep in the jungle. His unit had initially stored ammunition and food in traditional wooden warehouses, but within 6 weeks, tropical rot had weakened the structures dangerously. The wooden walls were soft with decay. Insects had hollowed out support beams. The buildings were literally falling apart. Patterson requested Quonset huts and received 12. The difference was immediate and dramatic. Steel did not rot. The curved design shed water perfectly, preventing any pooling that might encourage rust. Ventilation kept the interior dry enough to prevent mold on stored supplies. Within 3 months, Patterson had replaced every wooden structure with Quonset huts. He discovered another advantage during a Japanese artillery attack. A shell struck one hut containing ammunition. Patterson expected a catastrophic explosion that would level half the depot. Instead, the shell penetrated the curved wall but did not detonate the ammunition inside. The hut's ventilation had prevented the buildup of explosive fumes, and the steel construction contained the shell's impact. What could have been a disaster became a minor incident requiring simple repairs. In Alaska, where American forces guarded against potential Japanese invasion through the Aleutian Islands, cold was the challenge. Temperatures dropped to 40 degrees below zero. Traditional buildings cracked and split as wood contracted in the extreme cold. Captain Robert Morrison commanded a radar station on Attu Island. His men lived in Quonset huts that had been insulated with fiberglass batting and lined with plywood. The steel construction proved ideal for Arctic conditions. Unlike wood, the metal did not crack or split. Snow slid off the curved roof naturally, preventing dangerous accumulation. Morrison added oil heaters inside each hut. The curved shape created excellent heat distribution, and the metal shell retained warmth efficiently. His men were more comfortable than troops in wooden barracks at warmer locations. The real test came during a blizzard that lasted 6 days. Wind-driven snow buried vehicles and equipment. Visibility was 0. The temperature dropped to 50 below. Morrison's men stayed inside their huts, confident in their shelter. When the blizzard finally ended, they emerged to find some huts buried under 8 feet of snow. But the curved roofs had prevented crushing weight from accumulating. A few hours of shoveling cleared the entrances. By 1945, stories about Quonset hut durability had spread throughout the military. Soldiers trusted these simple curved buildings more than any other structure. They had survived typhoons, bombs, extreme heat, bitter cold, and every other challenge nature and war could throw at them. The official reports were impressive, but the unofficial nickname said it better. Soldiers everywhere called them the buildings that won't die. And they were right. August 15, 1945, Japan surrendered. World War II was over. In 4 years of global conflict, American factories had produced over 170,000 Quonset huts. They stood on every continent except Antarctica, sheltering millions of soldiers through humanity's deadliest war. Now those soldiers were coming home, and they brought memories of the sturdy, curved buildings that had protected them. But what would happen to all those huts scattered across the world? The military faced a massive logistics problem. Shipping all those structures back to America would cost millions of dollars. Some bases in remote locations were simply abandoned, leaving thousands of huts to rust in jungles, deserts, and on distant islands. But at major bases, particularly in Europe and the Pacific, the military decided to sell surplus huts to anyone who wanted them. The price was almost nothing. A complete Quonset hut, including all hardware and instructions, sold for as little as $1,000, sometimes less. For returning veterans who needed housing immediately, this was an incredible opportunity. Robert Garcia had flown B-17 bombers over Germany. He returned to California in October 1945 with his pregnant wife and almost no money. Housing was scarce. Apartments were expensive and hard to find. Then Garcia heard about surplus Quonset huts being sold at a nearby Air Force base. He bought 2 huts for $1,500 total. With help from 3 other veterans, Garcia assembled both structures on a piece of land his family owned outside Los Angeles. He connected them with a wooden breezeway, added windows, installed plumbing, and moved in with his wife. Within 6 months, their first child was born in that Quonset hut home. Garcia was not alone. Across America, thousands of veterans bought surplus huts and converted them into houses. Entire communities of Quonset hut homes appeared in California, Texas, and Florida. These neighborhoods had a distinctive look. Rows of curved metal buildings painted in bright colors, with gardens planted in front and additions built onto the sides. Other veterans saw business opportunities. In Ohio, a former Navy mechanic named Thomas Riley bought 6 huts and turned them into an auto repair shop. The open interior space was perfect for working on vehicles. The steel construction meant no fire risk from welding. Riley's business thrived, and he eventually expanded to 12 huts in Montana. A surplus hut became a diner. In Oregon, one housed a small aircraft hangar. In Michigan, a farmer used 3 huts for grain storage. In New York, an entrepreneur opened a dance hall in a modified Quonset hut that could hold 200 people. Churches discovered the huts were ideal for congregations that needed space quickly and cheaply. Dozens of small communities across America built Quonset hut churches in the late 1940s. Some later constructed traditional church buildings and abandoned the huts, but many kept using them for decades. Perhaps the most unexpected use came from universities. Millions of veterans returned to civilian life and enrolled in college using the GI Bill. Schools were overwhelmed with students and desperately needed classrooms and dormitories. Quonset huts provided the perfect solution. The University of California at Berkeley assembled over 200 huts to house married students and their families. These became known as Vetville, and the community thrived for 20 years. At Yale, huts served as temporary classrooms and laboratories. The Massachusetts Institute of Technology used them for research labs and workshops. Professor Elizabeth Warner taught physics at MIT in a Quonset hut from 1946 to 1952. She loved the space. The curved ceiling created excellent acoustics for lectures. The open floor plan allowed flexible arrangement of laboratory equipment. Warner once told her students that she had taught in beautiful traditional classrooms with wood paneling and stained glass windows, but she accomplished her best work in that simple metal hut. The huts proved remarkably durable. Structures built in 1942 were still in use in the 1960s, 1970s, and beyond. Some received maintenance and upgrades. Others were simply painted every few years and kept serving their purpose. In the 1970s, environmental scientists working in Antarctica needed shelters that could withstand extreme cold and hurricane-force winds. They studied various designs and kept returning to one solution, the Quonset hut. Modern versions, built with updated materials and better insulation, became standard housing at Antarctic research stations. When Hurricane Andrew devastated South Florida in 1992, disaster relief organizations needed emergency shelter quickly. Someone remembered the Quonset huts. Within weeks, modern versions were being assembled to house displaced families. The same pattern repeated after Hurricane Katrina in 2005 and other disasters. Military forces continued using updated versions of the original design. During the Gulf War in 1991, American troops in Saudi Arabia lived in Quonset-style buildings. In Afghanistan and Iraq, similar structures housed soldiers and stored supplies. The basic design that Otto Brandenburger and his team created in 1941 remained relevant 70 years later. Today, original World War II-era Quonset huts are still in use. A hut built in 1943 houses a small museum in Oregon. Another from 1944 serves as a pottery studio in Vermont. In Louisiana, a restaurant operates in a hut that once stored ammunition in the Pacific. These buildings have survived longer than most traditional structures built during the same era. Architectural historians study the Quonset hut as an example of perfect functional design. Every element serves a purpose. Nothing is wasted. The curved shape is strong and efficient. The materials are simple and durable. The construction is fast and foolproof. It solved multiple problems with one elegant solution. Otto Brandenburger lived until 1969. He watched his emergency wartime invention become a permanent part of American architecture and culture. In his later years, reporters occasionally asked him about the Quonset hut's legacy. Brandenburger always gave the same answer. "We had 60 days to design a building that would keep soldiers alive," he said. "We did not think about anything beyond that. We certainly never imagined families would live in them, or that they would still be standing 80 years later. We just wanted to save lives." He paused, then added, "I suppose we succeeded." More than succeeded. The Quonset hut represents something important about human innovation. When faced with desperate need and impossible deadlines, brilliant people created a simple solution that worked better than anyone imagined. They built something temporary that became permanent, something functional that became iconic, something born from war that served peace for generations. Today, scattered across America and around the world, thousands of those curved metal buildings still stand. Some are rusty and forgotten. Others are maintained and cherished. But all of them tell the same story. Sometimes the best designs are the simplest ones, and sometimes the solutions we create in crisis become the legacies we leave for the future.